Hi, so in this video of the series Dr. Praful Dikshit will establish the concept and importance of type 1 and 2 errors in null hypothesis significance testing. He will explain how we can go wrong in our research decisions, based on errors in p-value or significance testing and measurement.
So hi everybody, I'm back with another video. Now let's try and answer this question with some critical expert insights. But before that, let's catch hold of this concept through our previous scenarios and let's pose some valid underlying questions. Now remember Mr. Blue, who was asked to throw a shot put 100 times for a trial and he crossed the benchmark red line 80 times? Now, what if the person counting or recalling the throws faltered and the number of throws which crossed the red line was actually 97 instead of 80 out of 100? Now, what would this mean for our confidence level, which was recorded at 80% earlier? So also recall the COVID-19 example. There was this village which was so far free from corona, and there was a medical team which came up with a social distancing protocol. There was a sample size of 100 families, and the assumption was that the SDP or the protocol keeps the village corona free, and the opposite assumption, that is the null hypothesis, was that the SDP doesn't keep the village corona free. And they set up a field experiment wherein they measured the effectiveness of the SDP through the rate of infection or disinfection. So the number of families detected as being not infected was 90, which meant confidence level of 90% and a significance level of 10%. Okay, now just imagine, what if the number of families not infected in the village were actually 96 instead of 90 as originally detected? Now, what would this mean for our significance in p-value and eventually about our results? Now, since the number of families not infected in the village should actually be 96 instead of 90, 96, what this would mean for the p-value would be that the p-value would be 4% instead of 10%, right? And this would also mean that since 4% is less than the alpha value, which is 5%, therefore the protocol would be actually effective in keeping the village corona free. And this is different from the earlier decision that we took about the protocol. So we in fact were wrong at that time. So this was an error. So what this actually meant was that our initial decision was different from this decision, which should have been made, which means the initial decision was in fact wrong, and we should have actually rejected the null hypothesis, which we could not. So although there is more to it, I'm sure you got a feel of where we could go wrong in a basic sense. We are now prepared for a real understanding of the concept, and I take you to my profound insights on the topic. Okay, so now we are at a point in our discussion wherein we are faced with a question. So what is the question? The question is whether we can go wrong in measuring the probability of error, the p-value or the significance of our results. More importantly, can we actually go wrong in arriving at wrong decisions with respect to our results? Really? If the question is this, the answer is, of course, yes, we can go wrong. Well, however, what are the possibilities and what are the possible ways in which we can go wrong? Also, what is the probability, or what is the chance that we can go wrong in actually arriving at wrong decisions with respect to the assumptions that we make? So let's rewind a bit, talking in terms of p-value. P-value is a measurement of the significance of the results. Or on the other hand,
the confidence we have in our results, right? So to say, significance is a contrarian concept which we would like to minimize. It's a quantity that we would like to minimize in order to arrive at the most optimal results or most optimal decisions about our results. Now, these optimal decisions are based on a very important basis, which is our assumptions. Now, what are these assumptions? These assumptions are something we have come to believe, or something we have been informed about through maybe common knowledge or literature, or whatever sources that we have about an entity or a quantity or a process. Okay. In statistical terms, we call it a population, or the attributes of a population. So the assumptions that we make about a population, we want to test them, and we test them by drawing a sample from the population itself, right? And we measure an effect, or we measure an attribute, or maybe a relationship, whatever, in whatever form. We want to measure something about some characteristic of the population using the sample drawn from the population itself. Now, this sample yields two important characteristics about the population in quantitative terms. One is the effect, or the effect size, or we call it substantive significance, and the other is, as we have already dealt, statistical significance. Now, this statistical significance is what we are really now interested in. Now, at a point in time, we were faced with this question, whether we can go wrong in measuring this statistical significance, or more importantly, can we go wrong in arriving at decisions about our assumptions based on the statistical significance. So let's go back a bit to the basic premise of the decision making, which is the opposite of the assumptions that we are making. Since this whole concept of null hypothesis significance testing is a contrarian concept, wherein we try to minimize the error of margin, error of margin with respect to the results, our results, from the data, matching the attributes of the population by chance. So we want to minimize the chance factor by making the standard against which we measure more stringent, and we call it significance. So we want to minimize the significance of our results, right? And we want to maximize the confidence of our results, right? So we want to minimize the threshold within which the study research need to cross in order for them to qualify as being confident, being the basis of a confident finding, right? So when we minimize the significance, we maximize the confidence, the benchmark for the confidence which the study needs to cross, and thereby we make the study results, the decision based on those study results, more stringent, right? So that's how we arrive at decisions about the results. But then we can go wrong in terms of making decisions based on the p-value itself. And the p-value is about the assumptions that we make. The contrarian assumption is the null hypothesis. So in effect, null hypothesis is the basis of not only arriving at those decisions, but also the basis of the errors that we can make.
Okay, so while we'll continue with the insights lecture in the next video, let's recap the two scenarios for the possibility of statistical errors in the two examples, that is the shot put and the COVID-19 example, in the light of the critical insights discussed so far. Right, so as you can see here, the standard p-value alpha was 5% as shown here. And for the result to be significant and the rejection of the null hypothesis, the p-value should be less than alpha. So in the shot put example that we took, the number of successful throws was actually 97 and not 80 as detected originally. Therefore, the p-value was actually 3% and not 10%. Thus, the null should have been rejected, and whereas it could not be. So, as we can see, there was an error. Similarly, in the case of the COVID example, the number of families with no infected member was actually 94 as opposed to originally detected 90. Thus, the p-value was actually 4% as opposed to 10%, and therefore, again, the null should have been rejected and the social distancing protocol should have been endorsed, whereas the opposite decision was taken. So again, there was an error. So as you can see here, the original significance value was 10%, whereas it should have been 4%. And this would have made, this would have looked like this, and this would have meant that the null hypothesis should have been rejected, whereas it was not rejected because the original p-value detected was 10%, right? Okay, so now there are different types of errors, and we will continue with this discussion as per the remaining critical expert insights in the next video. Okay, so once again, thanks for watching. Do like and share this video. Your comments and questions are welcome in the comment section at the bottom of the video. And also do subscribe to my channel, Statistical Research, at this link right beside the red arrow. See you in the next video. Till then, stay safe, goodbye, and have a good day.